Alright, so in this video we're going to be talking about coterminal angles. Coterminal angles are angles that are on the same line and in the same position, but they have gone around the circle a different number of times or in a different direction. So, same terminal side, but it's a different number. We'll see what this means in a second. Okay, so in standard position, this would be in the first quadrant. Oops, these lines are not very straight. This is the x-axis. This is the y-axis. And this right here is the terminal side. In standard position, the initial side is on the x-axis, and this is the angle that we're looking at, so this would be theta. With coterminal angles, we'll see how it might move in a different direction than we're used to, or maybe it's gone around the circle a couple more times, and we'll see that in the next examples. So just real quick, to find a coterminal angle, you're going to need to add or subtract 360 degrees or 2 pi radians. And the reason for this is because this is one full length. This is one full circle. So in one circle there is 360 degrees and there is 2 pi radians. So when you are finding coterminal angles, you're going to have to move in a whole circle, otherwise it won't be coterminal, it will just be a different angle. Okay, so we're going to start by talking about positive angles. There is a difference between positive and negative angles. And really what this has to do is the direction that you move in when you're trying to write this angle. So if we have, this is the XY plane. In standard position, if we had an angle in standard position, we could have one elsewhere, but we would be moving counterclockwise, which is this direction. Or if we get out of standard position, it would keep going in this direction if we had our angle over here, and this would be the angle that we're looking at. Alright, and a negative angle, if we draw the same XY plane, we would be moving in the opposite direction, so we would be moving clockwise. So in this case we would start at this side, the initial side, and move in this direction. And if you see a negative angle, all you have to do is move those same number of degrees or radians, but in the other direction. So for example, if I wanted to move negative 180 degrees, I would move to here. This would be my angle down here, this area. If I were to do 180 degrees in a positive angle, it would go this way, and this would be my angle over here. Okay, so we're going to move on to our first examples. So example number 1 is to find the coterminal angles or angle of 405 degrees. So step 1 is to determine radians or degrees. In this case, we see right here that this is degrees, so we're going to be using 360 degrees instead of 2 pi. Okay, so step two is to subtract. So 405 degrees minus 360. And this is equal to 45 degrees. So the coterminal angle of 405 degrees is 45 degrees. And we see that this is in standard position, so this is the only positive coterminal angle we're going to find for this example. You could go on to add 360 degrees to 405. If you added 360 degrees, you would be going around the circle more times. So if we wanted to do this on the XY plane, because this is a positive angle, we would go around, that's 360, and then go another 45, just because it is easier for me to think about it in terms of how many 360 degrees do we have and then how much extra than to try and go around 405 degrees all at once. So this is the angle that we're looking at. We could go on to go around the circle another time, or another time we just add 360 degrees every time we did that. Alright, so this next example, we're going to immediately see that the difference is radians. So again, step one is to determine is it radians or degrees. So in this case it is radians, so we will be using 2 pi instead of 360 degrees. Step two was once again to subtract. So we're going to do 9 pi over 4 minus 2 pi. So the issue here is that 2 pi does not have this common or a common denominator with 9 pi over 4, and as a fraction we need to remember that to subtract there needs to be a common denominator. So this is easy to do in this case. We'll just multiply by 4 on the top and bottom. So if this over 1, we do 9 pi over 4 minus 8 pi over 4. And then we'll get pi over 4 radians. So this is the only answer we are looking for this problem. Alright, so this next example, once again, we're going to start step 1 is it degrees or radians? In this case, it is degrees. Degrees. So we're going to use 360 again. Step 2 is to subtract. So we're going to do 805 minus 360, and we get that that is equal to 445 degrees. Now hold on a minute. All of our other examples, we ended up with something that is less than 360 degrees or 2 pi radians. In this case, we're going to have multiple coterminal angles because we have 445 as a coterminal angle. It will be in the same position, and we will have at least one more coterminal angle. So we're going to subtract 360 degrees again, and here we get 85 degrees. So 85 degrees is like here. So for 805 we would have gone once, twice, and then stopped here. For 445 we would have gone once, and then, whoops, that's a little messy, but you get the point. So every time you go around the circle another time, you add a 360 degrees or 2 pi radians. Alright, so for this next example, we have to find the coterminal angles of 1110 degrees, but if you notice here, it's asking for the answer in radians. So 1110, remember step 1 is to determine is it degrees or radians. In this case it is degrees, so we're going to be using 360 minus 360 we get something that is too large, so we're gonna subtract 360 again, and might use my calculator here. I don't really know what 1110 minus 720 is off the top of my head, so I'm gonna use my calculator. 1110 minus 720. In a case like this, if you already know you're going to use multiples of 360, you could do that in your head to save yourself a step on the calculator. So we get 390, so I think I'm going to subtract 360 again. And we get 30. So I actually need to know what minus just 360 is. That's important because you need to know all of the coterminal angles. In this case, 1110 has coterminal angles of 750, 390, and 30. So we also had 750 degrees and we had 390 degrees. So these are all of our coterminal angles. We are going to convert one of these to radians and then use that to find out what the other ones are. So let's convert 750 degrees to radians. So I like to use 180 degrees and pi. Can already cancel out that last bit. I'm going to pull up my calculator again. And we do 75 over 18, and we get, oh boy, let's try and make that into a fraction, and make that 25 over 6, and don't forget that that is 25 pi over 6 because we left the pi out here. So 25 pi over 6. So I know that 360 degrees is 2 pi radians. They're equivalent. So if I make that into a fraction that has 6 in the denominator, I'm going to have 12 pi over 6. So I can just subtract 12 pi over 6. And I can do this mentally because it's pretty easy. So my coterminal angles are 25 pi over 6, 13 pi over 6, and then subtract it again, we get pi over 6. So these are the coterminal angles of 1110 degrees written in radians. Okay, so if you noticed, all of those previous examples, we were finding just the positive coterminal angles. In some situations, they will ask for both negative and positive. In this case, it is asking for just negative. So we're just going to find one coterminal angle. If you recall from the beginning of the video, when you are doing a negative coterminal angle, you're going to be subtracting 360 degrees or pi radians. So the steps are still the same. In this case, we do have degrees over here. So this is going to be step 2, subtract. We're going to do 60 degrees minus 360 degrees. And I know off the top of my head that that is negative 300 degrees. So this is my negative coterminal angle. And the way I would have this on a XY coordinate plane is that I would go like this, and I would start at this side and do negative 300 degrees. And it would line up to, oops, that's kind of 60 degrees. So this is negative 300 degrees on this side. This on this side is 60 degrees. Alright, so now we are going to do example number 2. Step 1, once again, is degrees or radians, and in this case we have radians, so we're going to be using 2 pi. And step 2 is to subtract. This example says to find just a negative coterminal angle, but I think just for kicks we should also find a positive coterminal angle. So we'll start first by subtracting 2 pi from 3 pi over 4. So first of all, we're going to do that common denominator, 2 pi over 1 times 4 over 4 is equal to 8 pi over 4. So we're going to do 3 pi over 4 minus 8 pi over 4, and we get negative 5 pi over 4. So this is the negative coterminal angle in radians. To find a positive coterminal angle for this, we would do this, but we would add 8 pi over 4. So we are going to do 3 pi over 4 plus 8 pi over 4, and we get 11 pi over 4 radians. So these are all the same angle, and 3 pi over 4 is going to be over, I believe, 3 pi over 4 is this, this right here. So 3 pi over 4, if you were going the positive way, would be like that. 11 pi over 4 radians would be going once around, that's 2 pi radians, and then an additional 3 pi over 4 radians. And then also we have negative 5 pi over 4 radians, so it would be starting here and going in this direction. So that concludes this example. So thank you all so much for watching, and have a lovely day. I hope you learned something about coterminal angles. Bye!